Hello, so today we are going to do this problem called diagonal traverse for a list of lists, and the problem says we want to return elements in a list of lists in diagonal order. And the order that we are looking for here in diagonals is going up, right? From the bottom to the top, right? And then one property that this problem has is that the lists inside, like the list that inside the bigger list here, don't necessarily have the same length, right? For example, here this one has length 1, this one has length 4, so it's not really a matrix. And so, for example, for this one where it's a matrix, the diagonals up is 1, and then 4 2 going up, 7 5 3 going up, and then 8 6 going up again, and then 9. For this matrix, it's 1 going up, 6 2 going up, 7 and then 3, because this list doesn't have any elements, so we don't include it. So 6 7 3, and then 10 8 4 going up again, and then 12 11 9 going up again, and then just to make it a little bit more clear, 12 11 9, and then 13 and then 14, right? So that's the problem. Now let's see how we can solve it. Okay, so let's take a look and see how we can solve this. So I have here the second example that we saw in the description, and we want to take the diagonals in going up, right? So the order is going up. So for example, here we have the first diagonal just 1, the second diagonal 6 2, the diagonal after that is just 7 3, the diagonal after that 10 8 4. You get the idea. So this is the structure here. The list don't have to be like the same length, right? But it still has the properties of the diagonal of the matrix, except that some values they just don't exist, right? So this touches on one of the main properties that is important for diagonals, which is that for each diagonal, I plus g is the same for all cells. The same for all its cells, right? Or values. So for example, the first diagonal, it's 0. If we just take a look here at the first diagonal, we have, it's just 0 0, so I plus j is equal to 0. But if we take, for example, the second diagonal, well, we have 0 going up, of course, so we have 1 0, right? So we have 1 0, and then we have 0 1, right? So I plus j here is always 1. 1 plus 0 is 1, and 0 plus 1 is 1. And then we can do it for other diagonals, but I'm just going to do some of them so that you can get the idea, but all of them have the same property. So for example, for 7 3, we have 0, we have 2 0, and then we have 0 2. And I plus j here is equal to 2. And if we had values here, for example, it would be the same use case. It would be 1 1, so 1 plus 1 is 2. For the diagonal, the fourth one, diagonal 4, the indices are so it's 10, so 10 is 0 3, it's 3 0 actually, and then we have 8, which is 2 1, and then we have 4 here, which is 3 0 0 3. So again, I plus j is equal to 3. You get the idea. So all of them have the same, each diagonal has the same I plus j value for every cell in it. Okay, so how can we use this property? So we could just, in our algorithm, in the first step, we could just create a map with key I plus j, right? Because all of them have the same keys. That will give us the values to be the values in the diagonal, and then the values are diagonal content, like diagonal cells, right? And so that would mean we can just go through the matrix, go through each cell in the matrix, and just put in the key add that value to the list on that key, right? So what this would mean is, for example, here we would have the first I plus j, which is 0. That one would have the list, just the first element, right? Because that's the only thing in it. The second one, which is I plus j equal to 1. So here are the key, and this is the values. So our key here, 1, the values are, the ones that will end up in it are 2 and 6, right? So now the question becomes, how do we order them? So right now we will just do the order of traversing each row first, all the columns in each row, which means that we'll end up with 2 first. And then since after that we'll go to the second column, we'll end up with 6 here. If we do the second one, I plus j equal to 2, then we will get 2, 0, and 0, 2. So 2, 0, which one will come first? The one with the first row. So we would have 3 first, and then we would have 7, right? And you get the idea. We'll continue doing this. Now, once we have this map here, how can we reconstruct it to get the final list of values, which in this case here, what we want to end up with is 1, 6, 2, 7, 3, 10, 8, 4, and then 12, 11, 9, and then 13, and then 14, right? So you could see here, this is the first diagonal, this is the second diagonal, but not in the order 2, 6 that we have here. It's in the reverse order. It's 6, 2, because we are going up. So in reverse, this is one element, so reverse order is the same as its order, so we could just reverse anyway. So in reverse order, let's just annotate that with R when it's in reverse order. 7, 3, it's actually, we get 3, 7 because we start with the first row first, so this is also in the reverse order. Same thing with 10, 8, 4, we will get it in 4, 8, 10 because that's the reverse order here, because we will start with the first row. And the same thing for all the diagonals. So in order to reconstruct the solution that we are looking for here is we just need to take all diagonal values with reversing each diagonal, reversing the order of each diagonal. And so we will just reverse the order of each diagonal, and then we construct a list from that. So that's pretty much the problem here. The main idea is that for each diagonal on a matrix, I plus j is the same for all values. And we can take advantage of that here, construct a map, and then get them in reverse order because we are going up. If we are going down, we'll use the order that going through the rows and columns gives us, right? So let's try to write this here. So the function that we are looking for, let's call it diagonal traverse list of lists, and we will get it, let's say, a list of values. Now we need a map here for the diagonals. So in Python we could just use a collections, and since each diagonal key will get a list, so that to not need to initialize the list every time, we can just pass to the default dict in Python list here. In other languages, you will need to check if the key doesn't exist. You will need to create the list, right? And now we can just go through the rows, each list, right? Each list in the overall list here. So to do that, we'll just say for I row in enumerate of the values, and then for j, and then the value in enumerating the row here, or the list. What we're gonna do is we wanna do this, basically take the key and add the value to it. And so to do that, we are just going to say diagonals of I plus j, we are going to add the value, right? And now once we did this, we will have finished the first step. So this is the step 1. We'll start our second step, which is reconstructing by taking the reverse of this each diagonal, right? So we'll need a list here so that we can return at the end. And we are going to go through each diagonal values. And then we can just extend the list by adding, as I said, we need them reversed, right? From the result here, we need them reversed. So we need to say diagonal. In Python, we can reverse using this. You could also call that reverse on the diagonal before adding it to the list. But in Python, we could just do this to get the reversed list. And then at the end, we can return the result. And that's pretty much it for this solution. Now, in terms of time and complexity, if we consider m to be the number of lists, and let's say n to be the max length of these lists, right? So for example, in our example here, the max length is 4. Then at most this for loop here will be O of mn, right? Because we are going through each list, and each list we go through all the values in the list. Now in terms of going through the diagonal values here and reversing each diagonal, so the reverse would be the length of the diagonal. The length of and then the diagonal values would be at most all the elements in the list of lists, so it's at most O of mn. So what this tells us is this is at most O of mn. Yeah, so that's pretty much it. This is the time. In terms of space, we are using this diagonal values, so that's O of, again, all the elements of the list of lists, so that O of mn space. So one thing here is that this is reversing, so this is O of mn reversing all the each diagonal, and each diagonal is at most m, right? So maybe this is kind of m squared, but we can actually improve this. So we could make this a deque so that we can append left, and that would give us the list sorted in reverse order already, and we avoid doing the reverse operation here. We'll see this in a minute. Now let's just type this first and make sure it passes on some test cases. Okay, so I wrote down the solution that we just saw in the overview here. So we need a map of diagonals. We go through each row, each list, and each value in the list. We add it to the diagonal in the right bucket that it belongs to, which is I plus j. And then we go through the diagonal values and add the reverse of the diagonal because we are going up to the result that we are looking for. I have some example here. Certainly not enough examples, but it should give us an idea. So it passes there. Now, one improvement that we can make here to avoid this reverse operation is we could use a deque instead. That will allow us to add to the front of the list, right? So which means that here we can say append left to add to the front. That way we'll end up with a reversed list, and we could just do this. And that still works. Now we could also instead get rid of this for loop here and just use reduce to get just one line instead. Yeah, if you prefer this is definitely fine and sometimes more clear, but this is also a nice use of reduce here, where we could just take a function and we will get two elements from the diagonals, two diagonals, and so to combine them we just want the concatenation, right? They are already reversed order, so that should be fine, and the list that we are going to go through is the values of the diagonals. The other thing is we need to convert this to a list because reduce gives us an iterable, and we need to import reduce, and that's pretty much it. And it should work fine on more examples. Yeah, so that's it pretty much for this problem. The main idea is to use I plus j as the key for the map, and then because we are going up, to reverse the order, or use a deque to insert in the front of the list. And that's pretty much it for this problem. Thanks for watching, and see you on the next one.